I created this video to show my daughters that mathematics is beautiful and full of interesting connections. Can you see the link between an apple to spinning wheels, a cup of coffee, a heart, and the concept of multiplication? If you have not seen something like this before, then it's gonna be a total surprise to you to see how the concept of multiplication with something like 2 times 3 equals 6 or 8 times 2 equals 4 can be turned into a form of art. And no, there was no slip of tongue there. If you want to figure out what I mean, please watch the video until the end. You can help your child have fun with math. All you need is a piece of paper, a pen, or a few colored pencils to create the art form that I'm going to show you now. So let's watch.
Wow, did you really create these yourself? These patterns are very colorful. Okay, but how do any of them relate with multiplication?
Alright, let me show you how to obtain such patterns using multiplication. To begin with, we will put 12 points on the circle and we will distribute these points evenly around the circle, starting with 0. So we have 0, 1, 2, 3, 4, 5, and so on. And the last point here is 11. Now, since there is no more space left for 12, it will go and sit along with 0. In other words, 0 and 12, they are the same points here. We treat them equivalent. And the next point, 13, will go and sit with 1, 14 would be with 2. So in a sense, what we are doing here is the same as a clock, where after 12 hours, the time starts repeating. For example, in military time, we have 13 hours, which is exactly as 1. So every number here can be placed along with one of these numbers from 0 to 11. For example, if you take 24, then we have to go around the circle twice and we will end up at where 0 is. In fact, you can see if you go around the circle 3 times, then the number 36 will also be sitting along with 0. So 0 is 12, it means all multiple of 12 are going to be equivalent to 0. And you can now try with 13. The next equivalent number would be 25, and so on. So once we have this set up, now we are ready to generate our pattern. And for this, we are going to use the multiplication table of 2, the simplest number for us. And let me show you first what I'm going to do, and then I'll explain. So 2 times 1 or 1 times 2 is 2. So therefore I'm going to join 1 and 2 with a straight line. Now 2 times 2 is 4. Therefore I will join 2 and 4. 3 times 2 equals 6. So therefore 3 and 6 will also be connected by a straight line. Next, probably you can see the pattern. 4 times 2 is 8. So 4 and 8 are going to be connected by a straight line. So essentially what we are doing is we are picking a number A and then we are multiplying it by the number 2 and the original number and its double, that number. These two numbers are joined by a straight line. That's all we are doing. Now 5 times 2 is 10, so 5 and 10 will be connected. So until now it's all very much like we do in the ordinary multiplication. 5 times 2 is 10. Nothing strange about it. And we are connecting 5 and 10. However, the next case is the first interesting case. 6 times 2 is going to be equal to 12. But as we mentioned earlier, 12 is the same as 0. So we will connect 6 and 0. Now 7 will go to 14. 7 times 2 is 14, but 2 equals 14 here in our scheme of things. Therefore 7 and 2 will be joined. And now the rest you can easily figure out, and eventually we'll get this pattern, which is pretty much symmetric and it looks nice. So one quick remark, you might have noticed that in the red we are writing 0 and there is a special symbol, and then 12 mod 12, similarly 1, that symbol, 13 mod 12. So this is the technical way of writing the fact which we explained, that 1 and 13, they are the same point. So it's written as 1 is congruent to 13 mod 12. So here 12 is there because there are 12 points on the circle. Now, of course, we can change the number of points on the circle and then explore different kinds of patterns. And that's what we're going to do now. So let's do it. So I'm not showing the points here. If you want, you can draw the points on a circle using a paper and pen, but probably writing a software program is much easier or much harder. It depends. Alright, so now when we do this, you can see some pattern emerging. And probably this pattern will be even more clear if we do it modulo, if we do the multiplication table of 2 modulo some big number. So let's pick maybe 101. So let's do that. And this time I'll simply animate it.
Wow, it looks like a heart.
Exactly. The beauty of this is not only we are getting a very symmetrical shape, but also we are getting something which we can recognize. Mathematically, this heart-shaped object is known as a cardioid. Pragya, what do you see?
I see 2 wheels, and the top one is rotating around the other one.
Yes, that's right. Look at the point P. What does it trace?
It traces the same shape.
Yes, isn't that amazing that the shape, the cardioid that we obtained using multiplication by 2 on a circle, the same cardioid, the same heart shape, appears when you rotate one wheel around the other and look at the trace of one point like P. Moreover, the shape that we are interested in also appears in many other natural places. For example, let's take this. Have you ever observed this before? That if you cut an apple into two equal halves, then each half of the apple will appear in the shape of a cardioid. The next example is even more fascinating. Take a cup of coffee and bring it near to a light source. Now, this source could be a torch or a light bulb. Try to adjust the relative position of your coffee cup and the light source such that you can see the shadow inside the cup. Okay? The mind-blowing fact is that the shadow is in the shape of a cardioid. Think about it. The multiplication that we carried out on a circle not only gave us beautiful patterns, but it also made a surprise appearance inside a cup of coffee. This is a theme that actually is very common in mathematics. Mathematics is beautiful, and it also is very effective in explaining natural laws, the laws of physics and other sciences. Alright, so now the question is why we are getting that shadow. I'll not answer it here, but maybe one thing to think about is the circular symmetry of the coffee cup and the reflection of light. Let us now return back to the circle and try something new like the multiplication table of 3. Let's see what happens if I do that. So I'm going to try 3. And we are taking 120 points on the circle. Wow, we are getting 2 petals. Now let's see what happens if we do it with multiplication table of 4. So we are still taking 120 points on the circle, and this is the multiplication table of 4, and we are getting 3 petals. Now Pragya, can you guess what will happen if we try with 5, which is the multiplication table of 5 on a circle?
So when we took 3, we got 2 petals. Now when we took 4, we got 3. So maybe when we take 5, we could get 1 less, which would be 4.
Let's see. Yes, you are correct. We are getting 4 petals. Now, it would be interesting to see if we take more number of points on the circle and change the multiplication number like the table, then what kind of shape we get. So let's try to do that. Let us have 168 points on the circle and consider the multiplication table of 55. We are getting a beautiful pattern. Let us take 216 points and consider the multiplication by 55. Wow, we are getting a beautiful pattern here.
Let me try. So how about we keep using the multiplication table of 55 and then change the number of dots on the circle. So let's see. Well, there's a line. Now there's more. Wow, that's symmetrical. These are some really interesting patterns. That looks like a donut to me. Wow. I guess multiplication can be interesting, but only if it's on a circle.